Okay, integration, annihilation. We're still doing it. Looks like I got square. This is the whole thing is a square root, kind of sloppy. So let me do some more simplification. Okay, so this is really just square root cosine x over square root of 2. 1 over the square root of 2 will end up being a constant, so let's just take that out of there. And 1 over square root of 2 is equal to square root of 2 over 2. You can simplify it now or later. I'll do it later. I got other things to do, like deal with this. And the way we're going to deal with that, well, u substitution isn't going to work. U substitution's not going to really give us anything that'll cancel out. We take u to be cosine x. We're going to end up with a negative sine x somewhere, and it's just not going to work. So what I'm going to do, I'm going to ask you to think real back hard to trigonometry. And you probably don't remember this because I forgot it, and I relearned it when I was a calculus student about this time of the year, so don't feel bad. This is an identity. Sine squared x equals 1 minus cosine 2x over 2. The interesting part about this identity is to realize that the coefficient of sine squared x, in this case, is 1. Well, your corresponding identity, the coefficient of the theta angle, the x, y, z, blah, blah, whatever, is always going to be twice that. See, we got a 1 here, we got a 2 there. In my original problem, I have a 1 there. So, you know, my identity, 1 has got to be twice the angle I'm taking the, the identity of. So basically what it translates to is I'm going to have to do sine squared x over 2 will equal cosine x over 2. Okay? That's sine squared of x. Actually, let's write it like this so it's less confusing. Okay? That's the whole thing. Okay? Okay, now we still get this 2 in here, so if we multiply both sides of this ensemble by 2, that should kind of get us where we want to be. So I'll do that down here. It's going to get sloppy. I should have done it over here. And then it looks like we end up with ooh, I ran out of paper. So, okay, so it looks like if we go ahead and do that, now we've got 1 minus cosine x equals, notice, see the reason we did this is we wanted to rewrite this as a square of something, because if we can rewrite it as a square, the radical will cancel out, and that's exactly what we did. Okay, so let's go ahead and let's just write this in another video, or in another, piece of paper. Okay. Okay. 2 pi is still there. Okay. And then the square root of 1 minus cosine x, well, that turned out to be 2 x sine squared x over 2. Okay, so now this is actually going to look a little more like square root of 2 times square root of sine squared, so we can actually pull this constant out. Okay, we'll pull the square root of 2 out. And then we're left with sine squared x over 2 dx. Okay, so we're left there. And that looks pretty good so far. Remember that essentially the radical and the square are going to cancel out, and so is this. This is just 1. Okay, so that's going to give us a 2 pi 0. Remember, we have to take the absolute value of what's inside, okay? Because no two negative numbers multiplied by themselves are going to give you another negative number. So we have to make sure that we are doing that. And if we look at this, it looks like we're going to end up taking the integral of it, and it's going to be, well, actually, you know what? Okay, let's do it. Let's go. This is going to end up being -2 cosine x over 2. And let's see here. You know what? Actually, this, okay, see this is a periodic function. This thing is, it's divided in half. So let's see here. This might end up equaling 0. So I told you this might be some trial and error. Let's just see if this integral works right here real quick. So let's go -2 cosine of 2 pi over 2 minus cosine of 0. Okay, that's going to equal -2. Cosine of pi is -1 minus 1. Okay, and it looks like, what are we going to have here? Looks like we're going to have -2. -1 minus 1 is -2 equals -4. Alright, so there we go. Or wait, no, it's +4. I'm sorry. Area under that area is 4.